Hello, Accelerated Math 7-8 students. We are still working in Module 11. The name of our lesson today is Unique Triangle, Two Sides, and a Non-Included Angle, and it can be found on page 78 of my comp book. So here is page 78. Let me move that out of the way. So again, remembering that we have to put titles at the top of each one of our pages when we start a new lesson. So unique triangle, two sides, and a non-included angle. The goal for today we will learn the difference between an included and non-included angle. Okay, the question that I want you to be thinking about is what makes an angle included? Things to know. The things that you need to know on this is we have to figure out the vocabulary and the terminology that makes this accessible. So an included angle is formed when two segments connect at a vertex and form an angle. So right now, this example says that this is 3 centimeters, and we do not have another segment. So what we have to do is we have to draw the other segment, and it has to connect to this vertex. And so what we're trying to figure out is, well, what size of angle was given so that we can draw it correctly. So the most important thing that you need to take away from these types of situations is that, again, they're going to give you some given information. So if they give you the given information for this one, and we're going to say that you have the side length of 3 centimeters, you have an angle of, let's say, 73 degrees, and then you had another side length of 5 centimeters, this is all that you need in order to figure out what the triangle would look like when you do that. So we have a 3 centimeter segment right here, and what we need to do next is we need to use our protractor, and we need to measure out 73 degrees. So I have to turn my book a little bit to figure this out, but here we go, turning it upside down so that we can figure it, because we're saying that the angle has to be formed by the vertex. So here's the given vertex of the line. So again, as a quick review on how to do this, you line up your line with the vertex, and then we have to find 73 degrees. So again, we're going to use that little marker tool that we have been using, and we slide it under and find 73. 73 happens to sit right about there. Okay, so then you make your little mark, showing that that's where it would measure at 73. Then we go back and we make a connecting point, and we have to be careful on this one because on this one it's supposed to be 5 centimeters long. So let's find a spot where we can easily do that. I'm going to start on 9, and I know 9 down to 4 is 5 centimeters, so there's 1, 2, right, 3, 4, 5 centimeters long. So there's a 5 centimeter long line. So I've done that. So that's 5 centimeters. I know that this angle right here, because we use the protractor, is 73 degrees. And so then all we have to do to make the triangle exist is we have to draw the third leg. And this right here would be a unique triangle because it has all 3 given parts. Okay? And it's called an included angle because I was given 2 segments. Here they are, 3 centimeters and 5 centimeters, and it is connected at the vertex to form the given angle. So the given angle was 73. So 3 centimeters, vertex, given angle, and the other side. And so this right here is a included angle because it's in between the 2 sides that were given. Does that make sense? I hope so. Okay, so if an angle is included, the included angle sits in between the 2 given sides. So you have to be given 2 sides in order to make the angle included because the angle has to sit in between the 2 given sides. Okay, non-included angle is exactly what it just says. Non-included angle is formed by 2 line segments connected at a vertex, and the angle sits at the end of one of the segments. Okay, so again, we're talking about the given information. All right, so on this one, we're going to say that our given information is 3 3 centimeters, of course, because I already drew it. So 3 centimeters, 5 centimeters, and 73 degrees. And we're going to show now how this one looks different than the other one. And it said in the instructions that the non-included angle is formed by 2 line segments connected at a vertex, and the angle sits at the end of one of the segments. Okay, well that's not bad. So that means instead of at this vertex being 73, I could say that the end of this segment right here is the 73. So that's what I'm going to do. Again, turn my book, okay, and I'm finding 73 degrees. So we'll go on this side this time, 73 degrees. So I know that it has to go this way, because if it went this way, that would be obtuse, which is way bigger than 73. So I need to find 73 over here. So that's 10. 73 is right there. Okay, so I make my little mark. Make sure that's exactly on 73, which it is. Okay, make my little mark. So there it is. And then I connect the end of the segment, right, like it said. Okay, and we're going to have to do some eyeballing because this is the given side, and this given side is supposed to be 5 centimeters. So again, we're going to go at the 9, and we're going to say that 5 centimeters has to be, so my picture looks kind of weird. How can we make that work? Because the 73 has to be down here. So this is 73 degrees. I think I'm going to run out of room on my book, but okay, so let's make sure that we maintain this. And then we have to figure out where 5 centimeters it would be. So it would be clear if our line extended a little bit more. We would say here. So let me get another ruler to see where 5 centimeters would be. I apologize. This is a little bit tricky. So it has to go, yeah, so they're both going to go off the paper. Unfortunately, I didn't leave enough room. But you will know that this one has to measure 5 centimeters, right? Which it doesn't because it fell off the paper. But where they intersect would be the completion of that one, okay? So non-included means that you are given 2 side lengths, 3 centimeters, 5 centimeters, and this time the angle does not sit in between them, it sits on another vertex, okay? And so that's how that one looks. I apologize for falling off the paper. Sometimes that happens, okay? All right, so that explains included angles and non-included angles. Going back to our goal. Today we will learn the difference between included and non-included angles. So that's 2 ways. Included means in between the segments. Non-included means not in between the 2 segments that connect. Okay? There's some other things that you need to know. They are a unique triangle only happens when a non-included angle is 90 degrees or greater. So let's look at this. It says a unique triangle only happens when the non-included angle is 90 degrees or greater. So let's talk about a non-included angle. So if this is the given right here, does everybody see that that's the given? So your given information, again, going back to this, is very, very important. The given information is that you have 7 centimeters, 4 centimeters, and you have a 90 degrees, okay? So now it's saying the non-included angle, so it cannot be right here because that would mean that it's included. So it's saying a unique triangle only happens when the non-included angle is 90 degrees or greater. So is this a 90 degrees? The answer is yes. Now, some of you are thinking, well, how do you know, Mrs. Nelson, where did you measure from? Well, where you have to measure from in order to understand this is you have to measure from the vertex that the 2 given sides collide at. So this is the vertex where the 7 centimeters collides with the 4 centimeters. You can't use this vertex or this vertex because this is not the side that was given. The sides that were given were these 2 right here. So basically, you draw your side lengths, making sure that it's creating that 90-degree angle, and then what you do is you take a compass that is the same length as one of your sides. This one happens to be the 4 centimeters. And when you draw your compass, if it crosses exactly at the same length somewhere else on the triangle, then you know it's not unique. So look at it. Does this radius touch anywhere else on the triangle that's exactly 4 centimeters? Well, it touches right here, but this from here to here is 4 centimeters. Is this side length of this triangle 4 centimeters? The answer is no, it's 7. So this triangle right here is unique because we can only do one of these triangles, okay? And so that's how we know that it's unique. And the only time that this happens is if your degrees is 90 or greater, okay? This down here is the counterexample, and it will explain what I was just showing you. Non-unique triangles only happen when the non-included angle is less than 90, okay? So let's talk about that for a second. So we have non-unique. So that means that there are many triangles that can be drawn that will fit the criteria. Non-unique, so there are many. Unique means there's only one. Non-unique means there's many. So let's look at this one. This one's kind of fun. So our given information on this one, looking at the drawing, that's the first thing that I would like you to do is I would like you to look at the given. So the given information on this one that we can find is we were given 5 centimeters, we were given 30 degrees, and if you look, these are exactly the same length. So the third thing given was that it was 2.5 centimeters, okay? Then the definition says that the non-unique triangle only happens when the non-included angle is less than 90. So right here is would be the included, because remember, included means that it sits in between the two given side lengths. So that's this over here. So the non-included angle has to be one of them that's not inside those two. So just like the one we did on the other page where we fell off, the 30 degrees sits over here. And so we have our triangle drawn, but look, there's more than one triangle sitting right there. If you take your compass again and you draw the length of one of the sides, we chose 2.5, okay, and you draw your compass, look at how many times it touches and forms an identical triangle, okay? And what that means is it connects to this side, to this side, to this side. So it doesn't create another triangle right here because this is 5, but it does create one right here. So does everybody see the triangle sitting right there? Okay, and then it does create one right here. Does everybody see the triangle that's sitting right there? So it says non-unique, so that means more than one. So we can create more than one triangle by using 30 degrees in the non-included angle, and each of the side lengths will still be 2.5. So there's 2 different triangles that can be built. Okay, that's what makes this non-unique. This one has to be unique because the degrees that were used in the non-included angle was a 90 degrees. Okay, I know it gets a little bit tricky. The coolest thing that I like about this is you need to practice. And the more you practice, the more it will make sense, and then you've got it. Okay, so let's go back to our goal. Today we will learn the difference between an included and non-included angle. The question that I want to see if you can answer right now is, what makes an angle included? Hopefully you can tell me that. We'll be looking for the answer tomorrow in class. All right, that's it for right now, guys. See you later. Bye.